or complex zeros. So we want to solve this quadratic equation by the quadratic formula. So we want to identify the A, B, and C. Notice that this equation is in standard form. For you to use the quadratic formula, you must have the quadratic equation in standard form. Standard form. We're going to identify the A, B, and C. So here's our A, which is 1. Here's our B, which is 10. Here's our C, which is 35. And we're going to plug it into the quadratic formula. Remember, you should memorize this quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And make sure it's all over. Now let's simplify underneath the radical. Underneath the radical is 10 times 10 is 100. And then 4 times 1 times 35 is 140. Make sure it's a subtraction. And then all over 2 times 1, which is 2. Now underneath the radical, remember that's your discriminant. So 100 minus 140 is negative 40 over 2. If you remember, when you have a negative, that causes some problems. That's an imaginary number now. So we have to remove that negative and replace it with an I. So x equals negative 10 plus or minus. I'm going to remove the negative and replace it with an I. And then I still have that 40 underneath as a radical over 2. Now let's break down 40. What two numbers multiply to 40? You can do 10 times 4, would probably be a good choice. If you remember, the square root of 4 is 2. Square root of 4 is 2. And then we still have that 10 underneath. Now I'm just going to multiply I times 2, and that's 2I. Now, if you wanted to, you could leave that alone as your final answer. If you wanted to take a step further, you can break it apart into two separate equations. So it looks like this. I'm going to go ahead and separate out as negative 10 over 2 plus or minus 2y squared of 10 over 2, so separate out into two fractions. And you can reduce this by a 2. So you're left with negative 5. You can reduce this by a 2. So x equals negative 5 plus or minus I square roots of 10. There are two solutions here. These are non-real solutions. So if you were imagined to go out and graph this quadratic equation, this parabola, you would not get any x-intercepts. Let's do one more example. Identify the A, which is 2. Identify the B, which is negative 2. And identify the C, which is 3. This equation is in standard form, so we can go ahead and use that quadratic formula. Let's substitute it in. X equals negative b, so negative b plus or minus b squared, so negative 2 squared, minus 4a a negative negative here turns that to a positive 2, plus or minus the square root. Negative 2 times negative 2 is positive 4. And then negative 4 times positive 2 times positive 3 is negative 24. All over 2 times 2, which is 4. Continue simplifying. Underneath the radical, which remember is your discriminant. So 4 minus 24 is negative 20 all over 4. Now I have a negative here. I'm going to replace that with an I out in front. Over 2. Now I can break down the square root of 20. As 4 times 5. The square root of 4 is 2i all over 2. And then you can break apart that fraction. I'm almost done here. So now I've broken apart that fraction. Now I can simplify. 2 divided by 2 is 1. 2 divided by 2 is 1. So our final answer is x equals 1 plus or minus I square roots of 5.